Okay. All right, so we're going to talk about monitoring and scaling. There is a lab associated with this, and then we're going to talk about automation and containers. So the lab for this is actually not that long either, actually. Configuring high availability. Yeah, so usually considered a 30-minute lab. So cool. All right. All right, good. We get to sneak in our 2 labs today. So we are going to go till 1 o'clock like we did before. So wait, what did I say? 1 o'clock? We're going to go till 5 o'clock like we did before. This time, though, at the end of the day, we're going to do some practice exam questions. I did talk to Greg briefly. He said that they are planning on sending out your vouchers for sign up today. So you should get another email. And yeah. So we're going to do some exam practice today. So we're going to do some exam questions. That's going to be fun. It's a little bit like playing a trivia game, except if you win, you get a certification. So, okay. Okay. Now, this question I kind of find a little interesting because it basically says, what factors do you consider when, you're considering how, whether to make a workload scalable? And it's like all of these, actually. I mean, criticality of workload, cost, usage patterns, expected growth. I don't know. Seems like a weird question. The sensible answer is that all of the above, right? But I don't know. It's a poll question, but it has a very, I don't know, interesting answer. Regardless, let's move on to monitoring and scaling. So everything starts with monitoring and logging. I don't know if everything starts with monitoring and logging. I feel like it starts with requirements and then translates into, design, technical design, that kind of thing. I feel like, but they did qualify it by saying as far as the operations teams goes, right? Everything starts with monitoring and logging. I guess if you're a pure support team, that makes a lot of sense. But even then, if you're not pure support, there's still metrics in there. So account usage, alarms, actions, distributing load, making things highly available. And then, how do we optimize resource supply, with AWS? How do we make sure that we are not overloading things? How do we make it so that things can automatically respond to scale within parameters we specify? Questions like, what tools does AWS have to monitor and log activity? How do I add high availability to my workloads? How can I set thresholds and be alerted to changes in infrastructure? And how can I keep capacity just ahead of demand and dynamically changing? So in this module, we're going to learn basically about CloudTrail, CloudWatch, and EventBridge, which used to be called CloudWatch Events. Like has ways to monitor both your account and the services that you're using. We're also going to discuss how auto scaling, which is in the center here, is going to be used to scale up and down based on usage and how to optimize costs. So we're adding some more components to our setup here. Now, as far as monitoring goes, where do you find the logs, right? Where do you find the metrics that you need in order to investigate an outage? So reasons to monitor, I'm sure you can figure those out, but basically you can't really manage anything that you don't monitor. So you gather information about utilization and performance, and you kind of set a baseline, and then you look for deviations or expected, not necessarily anomalies, but expected deviations, right? So CloudWatch is pretty much the metrics tool, metrics service inside of AWS. It has 11 subservices at my last count, which is like a month ago, underneath it. This allows you to collect metrics about services, metrics from operating systems, metrics from database systems. And it's really the only kind of official kind of integrator of all the metrics inside of AWS. When you start a service with AWS, it starts pumping metrics into CloudWatch. Now, they may not be very detailed, but you can turn that up usually. CloudWatch, by the way, can respond to changes in metrics using CloudWatch events, and it can trigger things like Lambda or SNS or other things. Now, it'll usually keep about 15 seconds of metrics. It will provide up to 1 second of granularity on metrics. You can dump in custom metrics if you want to. And the use case here is that, you've got resources that you want to watch and you want to capture things like CPU percentage, average utilization, read and write throughput, memory pressure, disk pressure, which by the way, are not captured by default. Memory utilization and disk utilization are not captured by default because those are operating system metrics and the rest of these metrics are all hypervisor metrics. So, Christian, as far as your answer goes, as far as like, is it CloudWatch events or Events Bridge? CloudWatch events pretty much triggers events inside of CloudWatch. Events Bridge is used for third-party triggers in and out, and it can include CloudWatch events. So it's now called Event Bridge for the most part, but yeah, Event Bridge has a bigger remit than CloudWatch does. CloudWatch events does. You can set alarms, by the way, on the metrics, and they can, once the alarm threshold is crossed, it can actually trigger a response. You get to control that. So when it comes to metrics, CloudWatch metrics or just CloudWatch is typically your primary use case. Now, memory utilization and disk utilization are not available by default, but you can run the CloudWatch agent if you want to on the system, or just push those metrics using Python or whatever, cron job. It's up to you. Now, that's all metrics. What about logs, right? Which are just basically, outputs from different other systems like applications, right? Or operating systems. And if you need information about your AWS account, you're going to use CloudTrail. This is not about services. If you just need information about your AWS account and what's going on, who did what and who started what, then CloudTrail is going to be your friend. If you need information about your networking, you're going to look at VPC flow logs. In other words, if you just need to know whether a packet was accepted or rejected, you're going to turn on flow logs and you're going to look at your VPC flow logs in purple. Otherwise, any other logs you're going to dump into CloudWatch logs or into a third-party service. It's up to you. And those are where your kind of application logs could live. Now, there's, Splunk and Loggly, and you could dump it into Elasticsearch, and Elasticsearch has its own, service outside of AWS. So the second and the fourth one, custom logs and CloudWatch logs, that's pretty much the same thing. When you dump custom logs, you could dump them into CloudWatch logs, or you could just pop them onto S3. Again, there's a lot of ways to solve that problem. If you decide that you want to store logs in CloudWatch logs, one thing to note is that you log events into a log group, and it's like a log stream. So from each particular source is its own log stream. Sometimes, for example, you might take all the products and stick them into a log group and say, hey, this is product A log group. This is product B log group, right? So a log group is just a group of log streams with the same like monitoring, access control, the same retention settings. That's all it is. These logs can then be converted into metrics that then you could run filters on. And if, like, for example, you're seeing a certain number of 500s over a certain period of time, that could trigger an alarm, which could do all kinds of things, not just send a notification. That's up to you. So just know that CloudWatch has a logs functionality. It also has a logs insights functionality that will allow you to run queries against these logs, kind of like Kibana, actually, or Grafana, if you're familiar with that. Although Grafana is a little bit more dashboardy. So CloudWatch does have a dashboard function as well. Now, CloudTrail, as we mentioned before, is not related to CloudWatch. This is a separate product. When you turn this on, it basically logs and monitors account activity across your entire account. I think accounts created after 2019 or something, this is turned on by default. So I don't know if the retention is really high, but you'll need to disable it if you're using some other facility to track all your API calls in AWS. This can capture, by the way, every single API call. If someone starts a system, creates a database, deletes something, adds a user, or modifies anything, any API call made against AWS will show up. But this is not to track the performance of your services. This is purely to track administrative API calls made against your account. So here's an example, by the way. Who shut down an instance? Who changed the security group configuration? What activities were denied? It's not just success, right? By the way, right? It's also denials. Here's an example log. Who made the request? It was an IAM user named Alice. What was the focus of the request? Well, that would be this. Looks sounds like a EC2 instance. And then in this section, you'll find where apparently they were calling the stop instances API in US West 2, obviously against EC2 based on the event source. The IP address originated from there, and it looks like they were using the EC2 API tools. So command line, maybe? I'm actually sure what the EC2 API tools are. But I suspect it's the command line. And then response was, hey, we're going to stop it. And our previous state was that we were running, but now we're stopping. So this is all CloudTrail. CloudTrail is showing someone hitting the account, right, and manipulating it. In this case, they stopped an EC2 instance, and it was Alice. So unlike CloudTrail, which is focused only on AWS API calls, right, or CloudWatch logs, which can just be a general repository for any logs you want to dump into the system, VPC flow logs can be turned on either at a NIC, a subnet, or a VPC level. So an ENI, Elastic Network Interface, a subnet, or a VPC level, and you can basically track all traffic going inbound and out of bound of that particular interface. So everything that goes in and out of a VPC, everything that goes in and out of a subnet, everything that's going in and out of a particular network interface. They are turned off by default. You can turn them on. You can write them to a S3 bucket, or you can put them in CloudWatch as listed here. You could diagnose overly restrictive security groups. You could monitor traffic that's going to your instance. You could determine the direction of traffic to and from a network interface. Flow logs are very useful when you're trying to troubleshoot network problems. So the hold on. That was Michael pushing the in button on accident. Note here that here is the content of a flow log record. Note that that's a really pretty way of looking at it. It doesn't look like that when you actually look at the log. It's actually really kind of jumbled. I think there's some open source tools that will allow you to make it look like this. But basically note that it has the destination and source IP addresses, the source and destination ports, what protocol was it using, etc. And was it accepted, which is actually pretty important to know. So that's a flow log, which allows you to track all the network flows inside of your VPC. Now you can push you can push these to CloudWatch. I believe you can also push them to S3. Obviously, if you push them to CloudWatch logs, every NIC, right, as an example, is going to show up as a log stream inside of the log group in question. So you can delete it when you're done. So. Oh, there it is. They went to CloudWatch, and they can also put it to S3. Note that when you do it on S3, it doesn't necessarily do it like real time. It basically aggregates it up into 5-minute intervals and then dumps it in. Because S3 doesn't really do real-time streaming. So you have to save it up to a file and then upload the file, save it up to a file, upload the file. You just do that in 5-minute increments. Okay. So that's all monitoring and logging, basically. Again, remember, CloudTrail is only going to track any administrative API calls made against your system. I want to start a system, I want to stop a system. If you're looking for application logs, you're going to need to externalize those either into a third-party system or put them in CloudWatch logs. If you're trying to get networking information, then you're going to turn on the VPC flow logs in order to get that. Now, what if you want to invoke events, like you want to create a notification if 500s get to a certain error, or if a web server goes down, if you want notifications on that. So this is where you create CloudWatch alarms. Is basically you identify the metric you want, create the alarm, like define the thresholds for it, and then just let it run. Now there's going to be a resulting action that kind of comes when you create the alarm. You're going to define what you want the response to be. The response, by the way, could be self-healing. Someone opens up a security group, right? Just to say that the source for that would probably be AWS config, which tracks all configuration changes inside of AWS. Probably wouldn't be CloudWatch alarms, but don't know. Now the alarm states, and this is going to be on the exam. So if you take the certification, they're going to ask you this, is that, if it's okay, then the threshold's not been exceeded. So you haven't triggered, in a sense, the alarm. If it's in an alarm state, that means whatever threshold you defined is exceeded. If it says insufficient data, that means either the alarm has just started, so the metric's not available, or it's suffered some kind of data loss, meaning like it's not getting data anymore from the system, right? So maybe the operating system isn't sending it data anymore. Sorry, it's super rainy outside. And I'm like, whew, my allergies are all kicking up for some reason. Now, a component, like when you submit a metric into CloudWatch, obviously you're going to put it into a namespace. Like EC2 could be a namespace, or a product could be a namespace, or maybe a database could be a namespace. And what happens is that a metric is a time-ordered set of data points. So it's got to have a dimension, like a name value pair, like for example, it's got to be like, CPU utilization, right? And so it usually combines, some kind of key with a value. So CPU utilization, and then there's a value to it, right? And then there's a period of time. So for example, and it's like, is it over 20 minutes? Is it over 5 minutes? Is it on a 1 second interval, 5 second interval, 10 second interval, 60 second interval? It's like, what's the period, right? Valid values are pretty much any multiple of 60 plus 1, 5, 10, and 30. So 1 second, 5 seconds, 10 seconds, or 30 seconds. The dimension, right, is like, what characteristic makes this value unique? Because everybody has CPU utilization, but how do I then qualify it? Like, what dimension are we talking about? So those dimensions could go, there could be up to 10 dimensions assigned to a metric, but typically it's things like, as you see here, the instance ID is a dimension, right? So that's a category so that each of those dimensions should be unique, right? So like, for example, it's the qualifier, like what is this metric associated with? Is it associated with an instance ID? Excellent. That's good, because every instance has CPU utilization, so I want to know it. Now you can set the threshold, and in this example, the threshold is a 25% trigger for CPU utilization. Above that, especially if it goes over a period of time, it's going to trigger the alarm. So here they've added some sustainability to it, which says, look, if you cross 25% over 2 time intervals, and notice this is set to 5 minutes, which is the default for CloudWatch out of the box. So if it's over 25% for 2 5-minute periods, then we're going to trigger the alarm. By the way, you can hit a checkbox inside your virtual machines called detailed billing. If you enable detailed billing, what will happen is that this will go down to a minute. So every minute it will capture the metric instead of every 5 minutes. These alarm triggers, by the way, can trigger events. Now, I think Christian was joking a little bit earlier of like, wait, are we talking about CloudWatch events, or are we talking about EventBridge, right? And the answer is yes, right? So EventBridge is a kind of a new extended version of CloudWatch events, because people were using it to actually drive event-driven architectures, and Amazon was like, whoa, we didn't really design it for that, so let's change it or extend it a little bit. What this means is that when an alarm threshold gets triggered, you can actually call a Lambda function or some other service to respond. You can actually also call a third party. So That's what Event Bridge changes, is that Event Bridge actually makes it so that you have this bus that you can put events on and they will trigger a response from AWS. You can also send events. So here, for example, is an example of the bus. Here, for example, is an example. Did you hear me just double redundant that? That was pretty good, wasn't it? Here, you've got event sources, in this case, AWS, custom events, and some SaaS applications. Let's say it's Salesforce as an example. And it's dumping into a bus that when the rules match certain patterns in these events, it's going to trigger either a Lambda function, a step function that's going to trigger Lambda functions, a notification. Like once it gets to Lambda, everything's in code, right? So you could trigger whatever a Lambda function you're willing to write. You want to trigger a Lambda function that then like goes over to PagerDuty and sends a notification. Great. You want to trigger a Lambda function that locks down all your firewalls in response to this particular IP address. You could do that. I guess my point being is that you create whatever rules and whatever code you want. So it's up to you. Super powerful, very open-ended, right? Here in this particular use case, you just, take an action in response to an event, and you basically, respond to events in an automated fashion. So by the way, this is fully managed. So this is going to handle everything from event ingestion to security to authorization to anything that's needed to kind of get this workflow to function. So this is really easy to build scalable event-driven applications. Event-driven architecture is like a thing unto itself that's kind of been sitting under the radar for all of these serverless options. You can think of it as, almost like a new kind of pattern to apply, kind of like microservice architecture. So the difference here is that event-driven architecture focuses primarily on functions as a service instead of running a full end-to-end application. So the bottom line is that what we just did is we went through Cloudwatch metrics, Cloudwatch logs, Cloudwatch events, Cloudwatch alarms, and I mentioned Cloudwatch dashboards. And then I talked about how we can use CloudTrail and VPC flow logs to capture AWS infrastructure and networking information, respectively. Questions? Did I put everybody to sleep?
Hey, Mike, I got a question.
Go ahead.
So maybe possibly events or alarms. I don't know if I heard you mention this, but could this reach into the OS and see that a process is not running and then send an email?
It could, but just to say this is that AWS does not like to cross the operating system boundary without your explicit permission.
Okay.
So if you want to see inside of an operating system, you have to install the CloudWatch agent into your system.
Okay, CloudWatch agent.
Yeah, and just so you know, there's a bunch of agents that you can install inside of an operating system. There's the CloudWatch logs agent, there's the CloudWatch agent, there's the systems manager agent. I'm sure there's other agents that I'm forgetting about. But the reason is that they don't want to crawl into your operating system. And so usually what they'll do is they'll ask you to turn it on and grant permissions to it.
Okay.
So that they're not violating any trust with you around what's going on inside your operating system. I mean,
Makes
because obviously
sense.
since they control the physical environment, they can get in there anytime they want to.
Right.
But they don't do that because it sets a bad precedent, right? So
No, that makes perfectly good sense. Thank you very much.
Yeah. Cool. By the way, if you use Amazon Linux, which is it used to be a RHEL hybrid, it's now more like Fedora based. The agents are there, you just have to turn them on and grant permissions to them. So if you don't want to deal with all that installation stuff, you can just use Amazon Linux. I don't know what the official identification and SLAs and stuff are for that. So you might want to talk to your operations/security teams to find out if that's approved. Regardless, let's talk about load balancing. All right, so load balancing is just the deal here is that we're trying to distribute load across a bunch of systems. We're even trying to path load, whether it's for mobile servers, that are feeding out mobile customers versus desktop customers, or maybe it's people who are in the Americas get this, or, you know, it's just, there's a bunch of different ways that you can set this up. Now, by default, you set up a listener, which listens with a predefined set of rules, and it will route based on what's in the URL. Here you see example.com, example.com/blog, and then example.com/mobile. Those are all examples of pathing. And this is primarily what an application load balancer will do, right? Is it will path by reading the suffix or the payload. Other types of load balancers won't necessarily parse the data like that. So Amazon uses elastic load balancers as a way of creating this virtual endpoint that then will redistribute traffic across all of the availability zones in a region. Load balancers will not route cross region. They are intra region only. This can be a layer 7 or layer 4. So you can go application level routing, or you can go low level network IP based routing. Just depends. They've even got a gateway that's relatively new called the gateway load balancer that actually acts as a tap. It can actually be kind of in line, or it can be something you send traffic to get it scanned and then have it sent back to you. It will use health checks, by the way, to talk to the backend devices. So it'll make sure that it's talking to healthy virtual machines or healthy containers, or even to Lambda, right? It'll make sure it's talking to Lambda. Here's the 4 types. I say 3 because the classic load balancer, I think, is going to get retired actually, either in August of 2022, or they're slating it for August of 2023. I can't remember. But they're retiring the EC2 Classic network, which is what they used to use before they created VPCs. And I can't remember when that was. December of 2013, maybe 2012. Anyway, so ALBs and NLBs are pretty much what everybody uses for load balancing. NLBs are really simple load balancers. They're super fast. They can handle a lot of connections. You know, they used to say like millions, like tens of millions of requests per second, but let's be very clear about that. Your mileage is going to vary depending on the type of connection. You know, I can't remember, some company a couple like months ago published a thing that showed they could only get a couple 100,000 of connections across the network load balancer, but they had a very specific workload. For the application load balancer, just know that this is a layer 7 load balancer, so it's only going to do web traffic. So 443 and 80, that's it. It'll do WebSocket and HTTP too. So NLB, if you really need it, just an IP and port-based load balancer. Application load balancer, if you want to do some complex pathing. Both the application load balancer and the network load balancer can have a static IP address. This just came out, I think, within the last 3 or 4 months for application load balancer. So I think the next chart even shows that it can't do static IP addresses, but it can actually now. And then the gateway load balancer just came out within the last year. This one is for third-party security scanning. Like this is for like signature scanning, deep packet inspection, that kind of thing. If you look at them, they all do slightly different things. Now ignore the classic load balancer because, like I said, it's going away. Shouldn't be using that. But the ALB is the one with the most sophisticated feature set. But the ALB is the one that requires the most horsepower to do the things it needs to do. Note the error there that says there's no static IP address for the application load balancer. There now is. Notice the ALB is the only one that does connection draining, but both the NLB and the ALB will both terminate SSL TLS if you want to do that. So what you need to know is that this is a virtual device whose job it is to take incoming connections and redistribute them. How it does that redistribution is very much dependent on which of the load balancers you do. Now we say that the gateway load balancer's job is a slightly different. So it's really built for third-party security devices that are either inline or side proxied with your like current network path. It acts as more of an invisible proxy instead of a kind of like load distributing proxy. But ALBs and NLBs are load distribution proxies. So their job is to distribute traffic across whatever servers you're feeding traffic to. Okay. Questions about auto scaling? Any of that before we keep going forward?
So, sir, so when do we use ALB versus NLB? Was right here?
So you use ALBs whenever you are wanting pathing, like you want complex routing inside of your, where it actually reads the payload. That's what you use an ALB for. So ALBs are used when you have to examine the traffic and its target and then redirect it somewhere else. NLBs are only used when you have a very simple kind of like set of servers. You're not doing any complex routing or any kind of justification about redirects or fixed responses. All you're doing is you're saying, look, when you hit this load balancer, this network load balancer, I just want you to send it to these 10 boxes on this port. That's it. So an ALB is for more complex routing functions, and NLB is just for very simple routing functions.
Gotcha.
Yeah.
And sir, if the target, how to say, so in the case of NLB, if you have, let us say, 4 EC2 instances that are part of the target group, so it sends the traffic to all of them, all 4 of them.
Well, it's going to send them at one at a time, right? So it's going to establish a connection for a client with like server 1, and then it might do server 2, and then server 3. It's going to try to spread the load evenly across.
Oh, gotcha. Yeah, that makes sense.
So it won't like duplicate the traffic and send it out. It's going to send them to one of the available servers on a per client basis.
I see.
Now I say it's not really per client, it's per like client initiated session. So they might initiate a new session, like they clicked on another thing on the web page, and instead of going to server 1, it'll go to server 3.
Gotcha. And the port number that is going to be passing on, I know other one you said ALB listens only on 80 and 443. How about this? How about the NLB?
Any port.
Any port? Okay.
Yeah, but it's not going to do any kind of filtering or analysis of the traffic. It's literally just going to forward it on.
So, sir, there is a port number of the load balancer itself versus the port number that is going to be forwarding the traffic to. So what I'm trying to say is that NLB listening to, let us say, listening on 443, and the EC2 instances that is going to forward the request to. So those EC2 instances should also have a security group that allows the traffic on that. Is that correct?
So yes, the security group, yeah, it needs to be allowed. Like it needs to be able to receive traffic from the NLB in question, right? So, yeah.
Okay, gotcha. Thank you, sir.
Yeah, and it's a little weird because NLBs don't have security groups. At least they didn't the last time I looked at them, because there was a big discussion inside one of the chat rooms about that. And but ALBs have security groups attached to them. So if you want to, you still have to get through the firewall that's wrapped around the EC2 instances.
Gotcha.
Yeah.
Thank you.
Yeah. Those are fair questions. All right. Okay, so now if ELBs are good at load distribution, and I just want to mention this, load balancing and auto scaling together are the secret sauce that make virtual machines awesome on AWS. I know people don't talk about that enough, but this allows you to go from one virtual machine to 5,000 if you need to within, the space of a few minutes. So auto scaling with load balancing is a great combination for like being able to maximize performance while minimizing costs. So even an auto scaling group, by the way, of 1 is actually very useful for your non-production machines that you don't want to get called at 3 o'clock in the morning for. So let's talk about what that is, right? Why do I make a statement like that? So here's how it works. So an ALB usually sits in front of an auto scaling group. And what happens is that group can grow those instances. So what will happen is that the load balancer might send a notification to Cloudwatch and say, hey, latency is at 150 milliseconds. That triggers an alarm in Cloudwatch, which in turn sends that data to the auto scaling group and says, hey, we're at 150 milliseconds. you have a policy inside the auto scaling group that says, look, if you hit 150 milliseconds, I want you to add 4 servers. So that auto scaling group then adds the 4 servers that you need. And then you might have another policy that says that when latency drops below 80 milliseconds, I want you to lose 4 servers. In other words, you get to control whether this scales based on percentage, based on number of boxes. If it keeps adding a box as the utilization goes up, right? You get to control how this thing auto scales just by giving it the dimensions that you want to do it. So auto scaling works by basically discovering what you can scale in the application, choosing what you can, like how you want to scale, and then track that scaling as it happens. So it's going to monitor your application based on whatever metrics you define. It's going to add virtual machines as needed in order to keep you at that metric. Now, there's a couple of different like versions of this because auto scaling exists for more than just EC2, but everyone talks about EC2 auto scaling. But you saw DynamoDB had auto scaling, Aurora has auto scaling. There's other services that have auto scaling. Now, the idea here is that how do we, in the old days, we'd have to buy hardware in massive chunks just to stay ahead of what we think is predictive demand. Then we actually looked at actual demand and it looks something like this. And this is a problem because there's a huge gap in the money that I spent and the money that I'm making. And over here, either the users are having a bad experience, right? Because my ability to provide capacity is way below the demand that they're generating. So these are all lost opportunities because they have now maximized my server capacity. I can't actually feed out these requests that are actually above that line. This creates a negative customer experience, which means they don't want to use the customer. The customer doesn't want to use the service. When we actually use auto scaling, what happens is demand stays just behind capacity. In other words, capacity stays just ahead of demand. And so what happens is that it just responds in real time to things as they are happening. This is why when I was talking about AMIs at one point, I was like, make sure you bake everything you can into the AMI because that'll make it boot faster in response to these kind of changes that you're seeing here. Now, here are the components of auto scaling. First, you have to define how are the EC2 instances going to boot? What AMI are they going to use? What hard drives do they have attached, et cetera, et cetera. That's called a launch configuration or a launch template. Launch templates are the ones that you want to use. Try not to use launch configurations if you can help it. This is going to have the AMI, the instance type, any security groups, any roles or permissions attached to the system. Then you're going to have VPCs and subnets along with load balancers, and you're going to define your minimum and maximum instances inside the auto scaling group. So how many machines can I have and what's the minimum I can have? And then what's the desired capacity? So I might max out at 12, minimum 2, but I really want 6 to start with. That's what you set up in the auto scaling group. So we've got the launch template, we got the auto scaling group, and then we've got the auto scaling policy. Now the policy sets the scaling type. In other words, am I going to do a scheduled version, which means at 8 a.m. I'm going to spin up a bunch of instances and at 8 p.m. I'm going to drop them? Am I going to do dynamic, which means, hey, I want you to track, I want you to keep CPU utilization at 90%. So I want you to be dynamic. I want you to add instances and reduce them, but I don't want it to go plus or minus 10 above 90%. And then you can also use predictive auto scaling, which is like, hey, you know what I want to do? I want you to figure out what I've been doing for the last year in AWS, and I want you to see what my growth curves are, and I want you to predictively show me what you think you're going to do to help alleviate CPU pressure. And what it does is it spins things up, has things go up in demand, and spins them down based on historical context. If you don't have any history, you can't use predictive auto scaling because it doesn't know what to look for. It doesn't know how to scale. There's no data to analyze to be predictive. Now the launch template again has the AMI ID, any attached network interfaces, any user data, right? Any pieces like that. The autoscaling group definition itself contains the maximum and minimum number of instances inside the system. You can turn the dial up and down within that maximum minimum framework. And then the autoscaling policy says, hey, here's my status checks, here's my CloudWatch alarms. Here are the things that I'm going to use to actually invoke a response on the system. It says, what do I do if this happens? That's what this autoscaling policy does. Now, just to mention this, inside the autoscaling policy, we've got scheduled, dynamic, and predictive. I gave you examples of these already, but scheduled is for known predictable workloads. Dynamic and predictive are really for general scaling and if you just want to use historical data. Excuse me. Now, here's the cool thing about autoscaling. You can create autoscaling fleets that are a mix of spot, reserved, and on-demand instances, and you can turn the dials on the percentages. So for example, you could say, look, this is my maximum spot price, and I want 10% of my machines to be spot. You can include certain types of reserved instances. You can say, hey, I want on-demand, this level of base, like a base level of on-demand instances. And you can set up the elevations there. Like what is my, what is the maximum number of on-demand instances I can add to that? They all support, by the way, the same lifecycle hooks, the same health checks, and they will schedule in scaling as if they are a single fleet kind of unit. You get a lot of elasticity here and a lot of savings, especially if you can use spot instances to cover some of the gaps and use reserved instances to cover most of your base. So you can combine multiple types of autoscaling. So if you want scheduled, predictive, and dynamic all in the same autoscaling group, you can do that, no problem. Because you might have different dimensions. You might have memory, CPU, disk pressure, latency. You might have factors that might say, hey, you know what? If this happens, increase my instances. If I go down, decrease my instances. You also might require different types of scaling. You might need to scale against multiple metrics. And the general rule of thumb is scale out aggressively, scale in conservatively. It's not Amazon like trying to get more money from you. They're not. It's them trying to protect you so that you don't scale in aggressively, then have to wait 5 more minutes because you're just now rebooting a system. They're asking you to scale out, and even if you don't need it, maybe wait a minute or two longer and then scale in, right? Questions of any type about autoscaling, just as a general statement?
Sir, I remember yesterday we were talking about, and today as well, about launch template and launch configuration. Mm-hmm. So for the auto scaling configuration, you need to create a launch template or launch configuration or both?
So you only use one or the other. So for example, launch configurations are down here. This is under EC2. In general, they ask you that you don't use them, right? This is the old way of doing things that was associated with auto scaling, and it doesn't have all the features that launch templates have. Launch templates under instances is what they actually want you to use. They actually want you to create launch templates instead of launch configurations. And these answer some of the same questions, but it has a whole lot more features inside of the launch template than it does inside the launch configuration.
Gotcha. Thank you.
Including like requesting spot instances, right? What do I do when I terminate, right? What do I do when I termination protection, all kinds of stuff. I mean, it's huge. Do you only want to force people to use the Nitro enclave, right? Do you want to force a particular kernel ID? It's all in here inside the launch template. A launch configuration, by contrast, doesn't have as much. It has some, but not as much in here. Notice it's very simple.
So to set up auto scaling, we need to use to use load balancer and set up auto scaling, we need to use launch template, not launch configuration.
That's right. And just so you know, your lab that you're about to do next is going to have you set up a auto scaling.
Okay, gotcha.
Yeah. Was there another question there? But I just want to make sure.
No, sir, I'm all set. Thank you.
All right. Which of these is a valid target for an application load balancer? Where I said it could be an EC2 instance. I said it could be a container. I said it could be a Lambda, right? So I kind of gave that away. Sorry. Yes. So we'll just give you that one. A, but good, Sean. You answered really fast. Good. I think those are the main three. Remember that Lambda can be a target for a application load balancer. You have an application with unpredictable traffic patterns that runs on at least 2 instances. You want the CPU utilization to stay at around 75%. Which of the scaling strategies would you use? Good. Yeah, it's not historical, which would be predictive, right? Certainly not manual. And it's not predicated on a certain time, so it's not scheduled either. So dynamic. Which service can invoke actions based on data from account resources and supported third-party management services? I hope I was clear on this. I think I mentioned third-party quite a bit for this particular service. Good. Looks like people were paying attention. EventBridge, right? EventBridge is really built for third-party service interactions. Okay. Which of the following are valid alarm states? So there's 2 of them. And the one that's missing is called OK. So what are the 2 that are listed here? Yep, good. Alarm and insufficient data. So it's okay, alarm, and insufficient data are the 3 states for a Cloudwatch metric alarm, right? Cloudwatch alarm. What is the typical use case for CloudTrail data? In other words, what 2 things could we use CloudTrail for? All right, so just to be clear, CloudTrail only monitors any AWS administrative calls that are made against the API, right? Not just administrative calls, any calls made against the API, which are mainly administrative calls. Do this, stop this, start this, delete this, give me information on this, right? So the main thing we're looking for is that to store log data has a record of account usage and capturing root login failures. That's what we're looking for. Provide real-time observability of AWS resources. That would be X-ray, which is we don't really talk about, but that's traceability and observability. Logging events for a particular service or application. Well, that's CloudWatch logs. That's not CloudTrail. Good. Okay, we're moving on to lab 4. Configuring high availability in your Amazon VPC. So our lab, basically the diagram here that we're following is that we are going to basically inspect the existing kind of lab environment. You're going to create a launch template, not a launch configuration. You're going to create an auto scaling group, and then you're going to test your application, and you're going to test the high availability of the application tier. Now, you want to configure high availability of that database tier, right? Which would probably be multi-AZ, and then make the NAT gateway highly available, and then you're going to test the availability of the Aurora database. So we're going to be back into this case, lab 4. Wow, it did it again. I'll have to check that again, actually, next time. But basically what's going to happen is that if you open up lab 4, same thing, right? And this does not have an optional in it, right? But please go ahead and just get started. Now, remember, it gives you about 2 or 3 times the space. This lab is slated to be about 2 hours. Sorry, 2 hours. Did I say 2 hours? 30 minutes, right? So it's basically about 30 minutes. So I'll check in about 30 minutes, which just to say this, it's going to be 2:30. So go ahead and get cracking on the lab, and then we will check in on that time and just make sure that everyone's good and there's no questions. Okay. I'm going to be here. Let me know if you need anything.